Two cars P and Q travel the same constant velocity along a straight level road. And the front of car P is behind the rear of car Q. At a given instance, both cars decelerate at 4 and 5 respectively, right? So let's represent red to be P, blue to be Q, and their distance in between them is 24. Okay. Write UVAS system for both of them, just to see roughly where we're at. So what's UVAS for P? It starts off at, what is it, 15 and... Oh, sorry, they both start off at 15. That's handy. A is -4. T, both times are the same because there's no time delay or anything like that. U equals 15, V equals that. A equals -5. And T equals T. Alright. The V values are 0. Why the V value 0? You care tell me? Yeah, they're gonna come to rest, aren't they? That's for part 2. Find the distance from there at rest. So the V value actually is only for part 2, so just temporarily ignore it. In terms of T, distance. So what do you reckon we do there? Distance. What formula usually gives us distance quite handy? Yeah, ut plus a half at squared would be a good way to go. Okay. Now, what we call, which one's the car that's behind? Oh yeah, that's P and that's Q. So let's go for S subscript P for SP, which is 15T plus a half minus 4 times T squared. SP is 15T minus 2T squared, alright? That went for 5 marks out of 30. SQ, which will be also 15T plus a half minus 5 times T squared. 15T minus 5 over 2T squared. That also went for 5 marks, so you're on 10 out of 30 already, okay? Now, the distance in between them. So let's take a simplification approach here, okay? Who's going to cover more distance? Who's going to have the bigger distance, ST or SQ? SP, same starting off velocity, but lower deceleration, which means it's going to travel for longer and faster. Everybody cool with that? Next thing we've got to figure out is we're going to set up a scenario where we know everything, right? So for argument's sake, imagine P went 100. Imagine Q went 50. What's the distance in between them in a scenario like that? No, because who had a head start? Q had a head start of how much? 24, didn't it? So how would you do that? The distance is 26, isn't it? Because you went 50 and you're 24. Gave him a 74. But how would you present that as an equation? I'd say it's SP minus SQ minus 24, isn't it? That gets you your 76, doesn't it? So I suggest you use the same thing here in terms of T. Back in the book has it presented slightly differently now, but let me see, just want to reread it. Find times of T between the distance between the two cars T seconds later. Is it a plus 24? So 100, take away 50, take away 24, we'll say that they're 26 meters. In that case though, sorry guys, just one problem there. What's the problem there? You're 26 meters out the other. You're 26 meters out the other side, aren't you? So there might be a problem. Let's go slightly smaller. let's say I went a bit extreme in the numbers I picked. Let's think about this a bit longer. Let's try what happened if you had 70 meters. Would this work? 70 take away 50 take away. That'd give us a minus answer, wouldn't it? So is there another way we could do it that would give us a positive answer when P is behind Q? It should be positive when P is behind Q, sort of negative when Q is behind P. Does everybody get that? So what would be a better system? Why don't we do 24 plus 50, take away 70, and what would that give us? It'd give us a plus 4. Plus 24 when you're 24 meters behind, and a plus 4 when you're 4 meters behind, yeah? So let's generalize this equation. What would I fill in here? 24 plus SQ minus SP. That's the general formula you want to use now, okay? If you're ever in a test, do stuff like that. Just toy around with different numbers. See how you do it with a really basic question. And then expand that to the more difficult question with the letters. And it makes things a bit easier. So that's what we're going to be dealing with this here. Alright, I'll go back up to the top now. Alrighty. So, do this in green. 24 plus SQ, which is plus 15t minus 5 over 2t squared, minus SP, which would be minus 15t plus 2t squared. And lo and behold, what's going to happen here? Huh? Yeah, I'll just put it in brackets, will I? I sort of did it. I did it in one step, but for argument's sake, we'll just do it in 2 steps. Alright? And a minus times a minus is there. Plus, yeah, that's alright. Shouldn't be skipping steps, so you're right. Now, what happens now? 15 t's, cancel. And what we're going to be left with? We're going to be left with 24. 5 over 2, 2.5, minus 2.5 plus 2 is minus a half. Okay? When you get this out, you're on 15 out of 30 marks. So this is your answer for part 1. And now you're currently on 15 out of 30 marks. Okay? Now, have another look up. Find the distance between the 2 cars when they are at rest. It's an interesting one. When they are at rest. Okay, let's bring the. Can I get rid of the first part? Can I get rid of all the workings? Alright. Alright. For me, I don't think you can. It says you can use the formula, but I suppose you're going to use the formula. I'm not that comfortable using that formula, to be honest. Alright, we'll try 2 different ways. Alright, here's what I would do. I'd get the time it takes for the slower one to go to rest. So what does that mean? What's the time for the slower one to go to rest? Huh? Yeah, it should be 3 seconds. Let's do phi equals u plus at. You're right, it's going to be 0 equals 15 minus 5t. 5t equals 15. T equals 3. Go with that? Now, how far did it travel in those 3 seconds? I always could have used phi squared equals u squared plus 2as, couldn't I? Could have got the answer directly if I wanted. Which me. Anyways, let's do it this way. 15 times ut plus a half at squared. Okay, lob all that into the calculator. It's going to be 45. Take away a half. What's it going to be? Minus 5 times. It's going to be 5 times 9, which is just going to be 45. So I can't see at home, that's a squared there. Okay. So what we have there is 22.5 meters is what that S took. Okay. I could have took a more direct route, couldn't I? I could have done v squared equals u squared plus 2as directly and got that. Okay? Out of interest, we'll try phi squared equals u squared plus 2as for the red data. We'll see how far the red card travels. Okay. So I showed you one method for the blue data. We use another method for the red data. What do we get here? 0 squared equals 15 squared. Are we expecting a bigger or smaller answer for the red data? Bigger or smaller S value? You should know. Why are you expecting bigger? Huh?
Slower deceleration.
Yeah, exactly. That's what we said earlier. 225 divided minus 8. 270. Whoa, that is completely wrong. Wait. What? I'm glad to get here to just do there. 8s moves to the left. 2 to 5 divided by 80. What was I thinking? 28.125. That's what we're expecting, wasn't it? The hell are we using that formula? To be honest. What am I going to do instead? I'll just lob it into this thing, won't I? And I should be able to find the distance between the two cars. So what's the distance? Anybody? 28 points. 125 take away. You'll need a chair. Go to the other room, grab a chair. Oh, wait. Plus that. And take away the other one. Alright, anybody tell me what the answer is?
24.
It's what? Oh, 24 to start. Sorry, my fault. I used to say a number twice, didn't I? And then what you get? That's what you get there? You should get 18.375. Is that okay? Now, out of interest, what would happen? I'm very interested in this myself, or I'm just interested in seeing if I could have done it any faster or any better, okay? Remember the time taken here? How long did it take for this one to go the rest out of interest? So let's find out. P equals U plus AT, green data. Now we have to answer the questions done, by the way. Full marks. No doubt about it. I'm just interested in something else here, okay? So I'm going to do B equals 15 minus 4t. I'm going to find out that 4t equals 15 and t equals 15 divided by 4. What happens if I log in the 15 over 4 into the original equation here? Will it come out as 18.375? Anybody tell me that? No. Anybody tell me why? That formula is meant to give us the distance between both particles. What went wrong with it? I think it only works if both particles are still moving. If they're not moving, one of them stopped completely. Because you understand it stops, it doesn't go backwards. They're assuming when t equals 4, they're assuming the one that stopped at t equals 3 then started to go backwards after that, because its deceleration then forced it to go backwards. That's why there's a discrepancy between the answer we have and the answer that we just got in the calculator. So just be aware of stuff like that. That's a very easy pitfall to fall into in that.